The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spent a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I am geologist Philip Ong, here with Mr. Dane DuPont, Hawaii Tracker, on Tuesday, May 4th, 2021, bringing you guys another Kilauea volcano update. We're erupting now into our 19th week here on Kilauea, but we are having some slowdown in eruption, at least on the surface. The big story is that over the last 2 weeks here, you can see in this photograph, upper part of the image here, from 2 weeks ago, April 20th, to today, we actually have had somewhere around half of the active lava lake surface crust over here. There's still lava underneath the surface. We'll talk about the details of that and show you guys all kinds of time lapses recapping this. But we're also gonna take some questions at the end of our broadcast, and Dan will answer some questions in the chat in the meantime. And in between, we'll cover monitoring signals as well to make sure that we cover all the bases for the questions and USGS photographs as well. So, all that being said, let's get started here with the time lapses. So we're starting off here with a F1 thermal camera USGS time lapse, and to play here, there it goes. So from 2 weeks ago, you can see this northern part and the southwestern part are the ones that are crusting over here. And the lava appears to recede from these ends back towards the middle. It's interesting, you can see there's movement of the little islets. And I'm going to go back and do that one again. Go through this a little more since we have a little more time here. the islets are moving around here quite a bit until they actually park themselves as the lava recedes, so the active lava surface withdraws back towards this exit point here. So this is the exit point below this west vent, which is still the active vent, and lava is still coming out. It hasn't stopped at any point that we can tell. It's just an active surface. So zooming in on the southwest corner here, you really can see this lava surface receding, and I really think it's interesting to look at how this little knob grows off here. And let's put that back one more time as well here. There it is. Right through here. You can see that there's something going on beneath the surface we can't quite tell, as the freezing process, the hardening, solidifying process is happening there. And here in the north, you can see this bobbing islet suddenly become fixed as the active lava surface withdraws. And in the grander context here, we have seen earlier in the month these squeeze-up ooze-ups around the perimeter of the entire crater, but we have not seen that really in the past 3 weeks now. And we presume that has something to do with the amount of lava coming out, or the pressure that it's imposing on that liquid lava, that because of that process, we believe there's liquid lava underneath this entire crust here. And USGS reports that on April 16th, they did a thermal mapping, and at that point, 93% of this entire area was already crusted over. So this recent change in the last 2 weeks, that maybe lost half of its remaining area, right? Half of the 7% that's left, maybe that means we're now closer to somewhere in a range of 97% or so, all the way crusted over of the entire eruption area, going back to December 20th, 2020. So I think that's interesting to point out there. And play the movie here. Let's go in. So in the grand scheme of things, you can see how it looks. You see that last 3-4% or so withdraw here from this northern, northeastern, and southwestern ends. All right, let's slow it down a little bit here. And this is still a time lapse. It's still pretty fast, but now we're looking at just the last 4 days here from the beginning of the month, from the beginning of May. So you can see what's happening more or less now. You can see the exit point is still consistent. Lava is still flowing essentially to the east, going underneath the edge of this old island, this original big island. And that seems to be the most dominant flow direction there. And you see the withdrawal. I'm going to put it back one more time here. Back. You can see the withdrawal and this overturning, foundering process happening here at the edges, here and here and here. But really, it's the margin of what's been warm has retreated from all the way up here to closer in a little bit here over the last few days. That's the main story of what it looks like now. And sure, we'll have questions of what it's going to do next, and we'll have to, of course, wait and see. There's no real telling. But the key thing to notice here is that it's still coming out beneath that crust on the one end, and it's still going back under on the other end, and that's the key information we'll probably use to answer some questions later, to try to imagine what might be going on in the future and all of that. Because naturally, we want to imagine what might happen in the future, and really hard to project sometimes. So view here from the south. This is the S1 camera. So you can see what it looks like nighttime, daytime, that process. West vent, exit point just below it, and there is that main flow direction right through here, and getting more marginal at the edges there and there. And you would imagine, it's hard to tell from this image, and maybe I'll just start the whole sequence over again. You would imagine at some point that as this active surface withdraws in, you'll start forming a levee feature more at the edges of the dominant flow region. And so it could be that that area ends up perching itself above the surroundings, right? And it's interesting to think about what might happen there, whether it might actually close itself off here, this little knob. Does this knob want to get across and go over this way? Well, that would be hard unless this whole back area was crusted over as well. And really that makes it more likely that you don't really obstruct this pathway in any way whatsoever, but really maybe the margins of that, and you might have a levied channel, essentially a skylet, essentially, right, coming out from underground over here and going through an exit point, emerging into the surface, traveling a short distance, and then resubmerging back beneath the crust there. Interesting to think about how that actually works out there. All right, so we'll come back to that later on. But let's look at the time lapses just in the last 24 hours, these automatic USGS ones here. Let's see if this one will load here for us. No, I think maybe this page is not generating the loops correctly at this point.
We have a $20 super chat from Natasha. Says, aloha. I think I am late. Thank you for all the work you guys do. Thank you for the donation. Mahalo.
Mahalo, Natasha. Yeah, not too late, not too late. We're just covering the recent change here, and we will, as usual, try to keep putting out our content in different formats, and so we'll put out a little summary of this at some point later in the next few days as well, for those who don't have quite as much time. But turning here to the USGS camera, I was going to try to show you this S1 automatic time-lapse, but it's not automatically giving us a loop today. So that's the static view of how it looks. You can't take much from that. So let's go to the F1 again. And here's the automatic 24-hour time-lapse actually generated working. So this is more of a snapshot of what's happening now. You still see that dominant direction here. And a lot less activity, although still occasionally foundering or possibly overflows from this upper elevated area coming down to the sides, right? Our update last week, we described how this southwestern area was reported by the USGS to be in a range of 10-12 feet lower than this perch level now because of the sagging, it actually dropping downward. And it was visible by seeing the edge of the crater, or the levee exposed over here, right? So as it degassed, compressed, and cooled, that surface dropped down 10 feet. So that process, you imagine, is repeating itself at the margin over and over and over on both sides here and here and here. That's interesting. It has that initial sagging effect, and then later on it can be pushed from below from replenished lava and then be uplifted as a more of a solid piece all around with that new texture in it. So interesting stuff there. I say that because the lava lake has actually spiked slightly higher than it was before. It's spiked up to 228 meters. That's 748 feet, I believe. It's dipping back down again, and there's a lot of pressure variations with deflation-inflation cycles in the volcano, and it seems to be following that, so that really it may be a increase, and we're measuring only in this area right in here, so we're not measuring it against over here. So long as this area right here keeps rising, then we can have a perched feature that might have, it looks like more of this shape right now. It's interesting, a spine growing here. There's a spine growing right in here. There's a spine growing right in here. So you can see it's trying to separate, and that'll be the interesting thing, is if it somehow is, let's say that we manage to not get it under that crust, and we can flow over top of the surface, and you can get some more interesting scenery happening there. So, but I wouldn't expect it at this point. I think we'll just wait and see. But interesting to see those little knobs right there and right there coming in, and one on this side as well. And so the process appears to be ongoing still. That's the bottom line, but definitely some sagging happening, likely in areas like this and here and here right now. Okay, so that's the F1 camera. And one last view. This is the KW camera. It's that same view as the thermal camera, but in visible range. So there it is, nighttime, daytime, really just that smaller area right in there. Moving on, let's look at some of the USGS photographs. Here we have a view of the lava lake on April 27th. And so it's similar to what we're just looking at, but a different angle. It's a little more similar to the S1 camera. So the original north vent way up here, and north is in this direction. Wekahuna Bluff, Jagger Museum overlook, all up in here. Kilauea overlook is somewhere up in here. So we're looking at the reverse angle, looking back. The west vent is back in here, and there is that 2 weeks ago was the active surface of the lava lake there, and more recently, smaller area like this. But this is still a week ago now, this photograph from April 27th, and so I'll zoom it in just so we can get a comparison there. You can see still just a little bit of different texture here on the north and the south, but these islets over here are clearly completely surrounded by that melt at the surface. Okay, so moving on to the 29th, release of the 29th, and here's a new compilation put out by the USGS. Go all the way in here. April 17th at the top, predating that last photograph, right? You still have lava in that northeast bay and in this southwest bay here, surrounding all the way around these islets here, and even wrapping a little bit into here. Although really this was a first area to start to founder early on, over a month ago in fact. And next it was over here in this northeast area. So you see a little bit of that different texture, a little bit more slabby back in here in this area compared to over here, but still overturning and still liquid red lava at that same depth and elevation all the way across. Moving to the 28th here, and a little bit easier to see those boundaries there and there. Boundary through here. So like that. You can see if we look in the original here, because we have in the past looked at some of the changes around the west vent area, and so it's interesting to see that there's still that crusting over process happening near the periphery of that perched pond, and it still is breaking apart the crust, and you see it happening right here as this image was captured on the 28th. Okay, so moving on, there's another. Oh, actually, wait. Let's not move on, because there is another series here of thermal images from that same angle. So April 13th, focusing more on the southwest bay, right there. There it is. You can see still that slabby structure on the surface, but that's normal appearance there, and that's still the normal circulation of the lava lake. By the 19th, you start to see a little bit less frequent activity. So the crust is forming and it's foundering less frequently, and so eventually it hardens all the way. And by the 28th here, a little easier to make out the edge of this perched levee up here, and an overflow coming across it, fanning into this now lower sagged area that has this dark lineation right in here, edge of the crater right there where it sank down. This might match that same level as here, but this lower area is all sagged down in there. So thermal images also appreciated from USGS. All right, now we'll look at the whirlwind. Whirlwind on April 29th, and so we've seen features like this time and again on the volcano, and just one more interesting to add it to the archives and the annals here. It looks like it's just a little vortex, nothing super exciting, unlike the recaps we did of the 1920 run eruption, where that thing was flinging up bits of lava and lava glass and lava shards and spitting them up in the rim. It looks like it's just a fairly innocuous gas-only plume of vortex there without any lava shooting up or anything like that. Still cool to see. Moving on to May 3rd here, May 3rd release. And this is detailing expedition on April 30th in the southeast to collect some of the, I believe, geophones. Let's see what the acoustic sensors here. HVO scientists hiked along the closed crater-rimmed road on April 30th to retrieve acoustic or sound sensors for a scientific study. So we get a little bit of different view here. You can see a view across to that upper Uekahuna Jagger Museum area, Mauna Loa in the background up here. And the pit of Halemau'u is right here, this foreground here. So more view along the road, you can see the road has been cracked and it's now got grass growing out of the cracks since there's no traffic through there anymore. Okay, back up to this first one. From that southern view there, you can make out this wispy SO2 plume right in here. Maybe a little bit over here as well. And that's reduced gas coming out, but still gas coming out. It's still detectable by people and can make fog. And of course, compared to the fog that there was even a few weeks ago, we're already hearing the cries of joy and relief from the Kona side of clearer and cleaner air. So still, for those not trained to see these little wisps there, so that's the SO2 plume in there. A little bit more in there, a little bit bluish, like a little bit clearish blue there. Gas vapor coming out right there. Right, so, and then one last one here. Look through in here. This is April 30th, photographed by Kendra Lynn, USGS-HVO. And similar as the last sequence we were seeing, where a little bit less glow, but the more silvery, smooth stuff is the active lava on the surface, which seems to be in his photograph, something like this. It looks like there's almost an overflow coming on there, but this seems to be a choke point right in here. That seems like it'll likely become part of a levee, right? And then attaching to this eyelet and that eyelet to make some boundary over here, and seems to be swinging all the way out to here right now. And all through here, this is that part where it's diving under, sinking in underneath the rest of the crust, right in there. And then somewhere over here, it appears like our levee, somewhere in the range up in here. I see some harder rock in here and possibly an overflow right there. But maybe a couple of different terraces of levees. Hard to really tell here. So I believe that concludes the photographic part of the recap here. There are a few new maps, and this is a release April 29th of the Rise of Halemaumau Lava Lake, a new DEM scan. And what they've done here is put in cross-section different dates on the left. So black is pre-eruption, yellow is December, and red is April, right? So the original filling of the lake from one level to another and another, and up and up and up. And look at the detail right in here. You can see that the island's profile as the surface rises, moves, and you see the island's profile was over here when it was lower down, and then it moves over here, and then it moves over here, and then it actually stays pretty much here. But you see it's still rising. It's still been rising with that entire other crust. Not as easy to make out the nuance here, but on this side, the surface is a little bit higher than behind that big island over here on the other side. And even that is higher than its far eastern edge way over here. Remember, we're seeing those ooze-ups as recently as the first couple of weeks of April coming up along the edge out through there. That's why we believe liquid lava underneath that entire crust that is being buoyed upwards, right? Like a cork bobbing on top of this filling cauldron down in here. So that's one view of the filling lava lake there, and another view of it, updated outlines, and similar story, but looking straight down here. And the lines get closer together towards the outside because as the lava level has slowed down and the crater has gotten wider, as each successive time increment doesn't really increase the perimeter as much as the previous time increment there. Really fast at the beginning and quite a bit slower, really, ever since. So that is our lava lake filling. The lava lake filling has had some relation to the tilt, so let's look at the tilt for the last week just to start. And we came out of a deflation-inflation event. And had another one in the last week, came back up, and now we're piddling and just waiting to see what happens next year without a whole lot of big change, no inflation or deflation happening. And so we'll look just to look at the last week first. Let's look at the lava lake levels, and so click it on here. I'll go back and forth a couple of times. You guys here, so you can see when we have that similar hump and the lava depth responding to the inflation, deflation, inflation again. So this highest level right in here, 227.8 meters, not quite 228, it rounds to 228, but that's the highest peak so far, and we got close to that again today here, responding to these inflationary parts of the curve. Still have the smaller variations, probably some gas effects, possibly some small tidal effects. It's hard to tell exactly. And I don't have enough information and haven't gone through all of that. So but certainly there's other variations apparent here on the graph, right? Small ones of that size, bigger ones of this size, and occasionally you get this deeper one like that. Right? These ones that are swinging up and down a lot more. Overall, that average level going through there does not look that dissimilar to that 1 week tilt plot there. So the 1 month plot is a little bit skewed because of some reflections off some gas. So we're skewing our scale here, top to bottom. So you really don't see a whole lot of change. We're at 227. We were at 227 around the 14th. So really the last 3 weeks or so since the stagnant crust, we really haven't changed the depth that much at all. Just a couple little spikes here and there. Next week we'll have a much better view. We'll be able to compare the ups and downs of the month to the month tilt. As you can see, there have been quite a lot of deflation-inflation events ongoing. We've had 7 in the past month, 2 in the past week. Sometimes they stack one after the other. This one over here was a big inflation in between, but turned right back into deflation soon afterwards. And now we're really not changing a whole lot right now. But the most important thing here is our So2 values. Let me zoom in so you guys can make sure to see this one a little better. And tons per day on the left, 1 month at a time on the right. So all of the most recent measurements have all been in this range, essentially below 550, mostly below 500 tons per day. And the average value from mid-February to mid-April reported by the USGS was over 800 tons per day. So you see a little bit here. These last measurements are still falling in at 800 ton per day average, right? There were some ones that were lower previous to this off the graph as well. So these are a little bit on the higher end of that average. But you see that quite a difference from that average level beginning of April to the average level here at the end of April. And this is despite no correlation from that to our deflation-inflation events. We've had deflation-inflation events the entire time, and really the gas levels have changed from here to there. Right? So that's really why it's noteworthy. Is we cannot tie it, we just cannot tie it to the deflation-inflation patterns as it did before. Okay, so here's their most recent daily text update. And still erupting. Their most recent official report is still 227 meters, 744 feet. I call it 745, depends on how many significant figures you're using there. And So2 values 475 tons per day. It's the last measurement on May 2nd, 2 days ago. And so there's their average of 800 tons per day from mid-February to mid-April. Minor anything else there. They were not noting any change in the east rift zone, although, as we've noted now for a couple of updates, we do see some changes happening there as well, and will not be surprised to see this get updated at some point as well. They are also now noting lava has not oozed out along the perimeter of the lake over the past week as well, so they're now noticing this as well in their update. And they're still referring to 93% on April 16th, right? And so by now, we might be up to 97%, somewhere in that range, something like that, 96, 97%. All right, so here's the area that I highlighted that I want to make sure I got to you guys, because this is a new thing that they've been putting in. Recent So2 emission rate measurements suggest that the effusion or eruption rate has decreased significantly since mid-April. Other decreases in emissions during this eruption have occurred while summit tilt was decreasing, whereas the recent lows in emissions are independent of summit tilt. Drops in SO2 emissions are commonly related to decreases in lava supply. Other possibilities also exist. It is common for eruptions to wax and wane or pause completely. It is unclear if the current decrease in activity will continue and conditions around Halemaumau crater remain hazardous. HVO continues to monitor Kīlauea volcano closely for additional signs of change in activity. So, bottom line, a pause is possible is a way to summarize this, right? A pause or a change in eruption is possible. Doesn't mean it won't restart or it won't have another vent, and we've discussed all those possibilities, and they're just possibilities because we really don't know all the ins and outs of the volcano, and we essentially wait and see what it does. But we know the range of possibilities of opening a new vent, of shutting off and not restarting until you build enough pressure in the long term after several months, right? Or persisting at a low level indefinitely for years and years and years. Those are all options still on the table here. So, but a pause, waxing and waning, it could slow down, it could speed up. That's what they're getting at here. Right, so, interesting changes here, and we'll look at how the rest of the volcano is reacting and responding as well. We've gone over the tilt here, so we'll scroll down on the information page to the GPS. And on the GPS, let's look at this Caldera distance north to south on Kilauea. And this is something that was increasing at a faster rate up until before April, and then it actually slowed down in March. Seemed like it might have sped up here the last couple of weeks, but now it seems to be reverting back, and so this might be some smaller term adjustment really in the end, since that trend established. We haven't deviated that far off of it. We have, but we've come back to it now. So it does not appear that we are headed up. It's not clear with all the noise where we're headed, but we can say that this level right in here is the same as it was 2 weeks ago. Essentially no net change despite all the variations there. Right, that's really the only takeaway you really can get with any confidence here in this right part of this graph over here. Right? Similar amount of noise back then, similar amount of noise now, and you imagine it looks pretty similar all through there. And something did change in between. In the net, we're back to where we started. Right? So that's the summit, showing what might be possibly a sign of that slowdown as well. It's worth pointing out that we have seen these dips before, corresponding to the big deflation-inflation events. Oop. It's an arrow. There, and there, and there. So we have had a lot of deflation-inflation events. This could just be another one of those, and it could come back up, and we'll have to wait and see what's going to happen here. Right. All right. Let's go down to the East Rift Zone measure here. Let's skip past the 5-year and go down to Pu'u cone. And similarly here, it appeared that we had stabilized, but even with the noise, it appears that we're now on a downward trend again, similar to what we had earlier on. And so this was the filling of the rift zone lead up to the eruption. Eruption begins here in December, and then we are emptying the rift zone, and it seems to stabilize. But now we're resuming that emptying it, perhaps, or contraction at the least, right in there.
We have a $20 super chat from Bash on YouTube. It says, "Mahalo guys, you can just call me Bash."
Mahalo,
thanks,
Bash.
guy. Thanks, man.
So that's the trend from the one line across the East Rift Zone at Pu'u. But let's dig into it a little bit more here, and let's start at the summit at Wikahuna. Now we're looking at these 3 component graphs. So east at the top, north in the middle, up at the bottom. And this signal here is our eruption, right? So that when it happened, this is now a 2-year plot along the x-axis here. So really, I'm going to not focus as much on the absolute value of meters here, but I'm going to instead try to zoom in so you guys can see this recent nuance, right? A little bit of a change here, a little bit flatter, than before, right? That's the north. The east, not as much visible, but perhaps most striking to me is the up. The up is often really, no matter what other wiggles are happening, it's one of those versions of truth there, right? It always keeps you grounded, because if it's still rising up, then something's happening, pushing from below, right? And it doesn't matter the left and right wiggles. So you can see that despite other wiggles in other components, we were building up ever since 2018, up, and then up faster in December. Really only dropped down during that first week of relief of eruption out of the north vent. And since then, we have still been moving up. Not as quickly as in build up to eruption, right? But as quickly as we were prior to that. Still moving up. And perhaps here at the very end, this last week, and caveats as usual, we do not appear to be moving at the same rate of up. We'll have to wait and see if we noise and come back up here, but it's starting to look a little iffy there, maybe, right? And if it was just one station, then maybe we can ignore it. So let's keep looking down, and we look at the outlet around the Caldera as well, and it's showing a little bit of a change. This is the east component. North component isn't very different, but the up component, you can see it was going up, came down, stabilized, was going up, and maybe what's going on there, it seems to be changing trend once again. Okay, this station is Byron's Ledge. East, subtle change still visible there. On the north, it's visible as well. And on the up, the first drop on the up, it's been steady ever since December, really, or January, let's call it. Finally, reverse in the up, Byron's Ledge there. So those are not, those are signs we were looking for previous, when people were asking this eruption, could it end? We're saying, well, patterns would lead you to believe that, but the signals aren't showing any sign of that. We're just seeing extension, things moving up, and it seems like it's filling still, despite lava coming out. So that's the change we've really been seeing, and maybe that's the most significant thing in the long term. And we'll have to look back in a few months and we'll say, oh, was that significant at that point in time, right? So right now we really don't know. So we can keep going around the summit. Here's Crater Rim, and Crater Rim also, it's up, appears to have changed trend, right? If we look at this envelope right through here, seems like it should go all the way up here, and that's what we're not getting at. Seems like possibly it's more flat than anything, not rising up there. On the East Rift, Mount Ulu, you don't see a whole lot of change in the east. It's still getting pushed to the east. There's really not a whole lot of change in that. Maybe the magnitudes aren't as big as some other places. North, hard to tell. Maybe it's a little bit less mobile right in there, and not a whole lot visible on the up there, right? So it's not a lot from Mount Ulu you can gain. Kana no Yohamo, the east is still moving that direction. I'm glossing over this because there's some dynamics with the south flank that can push and which blocks are moving and all of that. So without getting into all the details, there's other reasons why this east or east component could be moving. In the past, it was because it was getting pushed by magma filling in the upper east rift zone and a summit area to its west, and that's what was pushing it east. So, but if we look at the up, for example, we can see that we're actually dropping down, and so we're not really getting pushed to the east. We're almost falling to the east instead. It's a little bit different when we start incorporating all the different components here. And the north one's really interesting as well, because this one seems to be sensitive for some reason, right? It was filling in prior to the eruption, maybe reached some capacity, getting a little bit more full as the summit fills as well. And here's our intrusion that happened at the summit, relieves it slightly. And then we have eruption, and we have the east rift zone refilling at rates similar to prior to the eruption in 2000, 2 years before that, right in there. That's similar rate right in there. And then just more recently, now it's finally turned back the other way and sagging back to the south while going down. And this is a lot of detail for, maybe not for everybody here, but for those of you guys that are following along, you can check me if this is incorrect. But I'm trying to give some evidence here of these more recent changes, especially in the last month here, right? On all the different components. down the rift zone here. Kind of know or Kamamoa, the station here. Pu'u we were looking at in more detail because this one is showing a little bit more scatter, and that's what's leading to that distance plot showing that downward trend right in there. And so you can see the north especially showing a drop, and the east as well. And Pu'u has been going down, so it's still going down. Not a whole lot of change in that regard over there. So a little further south, south of the East Rift on the south flank, you do see more down, more east. In this case, more to the west, and not a whole lot of change here. Slightly more to the south. Okay, because we need to check what's happening in the lower East Rift zone all the time, we'll move further past Pu'u to Jonica Station, and we do not see any of these shorter term changes here. Possibly on up very, very slightly, but really it's, if anything, if I look at this north component, it's getting a little bit steeper, so it may be, we might be having south flank movement in that area, or settling or sagging, or some deformation process on the ground that's independent of magma happening at a different rate, right? So it could also be that as magma was pushing in and possibly widening the rift zone up rift, now that it's sagging back, it's able to contract back, or something along those lines, or something, you know. So that's the kind of thinking that I would use to address that data set right there. Okay, so that's the East Rift stations. I'll stop it there, and we'll do one last thing with the data here, and that's the earthquakes. So we still have Pahala earthquakes, deep area down in here, a little bit Mauna Loa, nothing worth interrupting Kilauea for. And Kilauea has actually had a little bit more of these earthquakes. The summit region and a few in the south flank. They don't show up as well in this USGS plot. So let's go to the automatic USGS one that generates all the small ones, and we can see a little better here that you do have a little bit of activity here around the summit. It's nothing major, nothing alarming, but it seems like as the pressure is changing, that there's adjustment happening with the rock as well. So. Maybe like the sagging, emptying water hose, or balloon, or however you imagine it there. So just up in here, nothing on a rift zone all through here, all pretty empty in fact. And really it's to the south of there, on the south flank, that we're still seeing this background action still all through there. Right? These plots, these earthquakes here are colored by depth. So the red and oranges and the yellows are the flank earthquakes. The blues are deeper ones. The magma pathway from Pahala down here in the southwest, coming over and eventually coming up. Right? There's a little bit of Mauna Loa adjustment here. That's the Kauiki area and deeper area of Mauna Loa. Mauna Loa flank also having some action right in here. So that is the automatic USGS plot. And to do something a little different, I'm going to animate the earthquakes here for you guys over the last week. See, there's those summit ones. There's no clustering. They just happen at a fairly regular pace, and so no big ones, no aftershocks, no real sequences or associations really that are obvious there. All right, so during the last month here, you can see we're still around 30-35 earthquakes per day. That's not unusual. It's essentially still the background, and it varies up and down across the whole past month. And here it is for the past year, so a lot less, still low levels compared to prior to the eruption, and even to the era in the build up to the eruption, we were still quite a bit higher than we are now. And finally, I just want to mention there is a new volcano watch out from USGS-HVO as well. This week is the rise and fall of lava lakes, and they are referring to some new research that has been published on associations of lava lakes being essentially pressure gauges for the volcanoes, not just at Kilauea, but at Ambrem volcano on Vanuatu, and also at Nyiragongo in the Congo. And so interesting stuff there. If you're going to go dig into that a little more, that is posted on hawaiitracker.com. And just a little bonus for you guys here, just a little cross-section from Ambrem that in December of 2018, same year as Kilauea, in a much shorter event that only lasted a few days, had lava lakes at the surface that drained away to feed a dike that went down its east rift zone. And in this case, it actually went all the way offshore to lead to a submarine eruption that led to floating pumice up in there, right? So similar kind of thing. I won't go into there's a lot of other complexity and details in there, but this probably reminds you a little bit of things we've seen for Kilauea before there. Right, so hawaiitracker.com. Go check out our written articles there and our recaps on there, and return to Dane to help us say our mahalos and talk about some questions here.
Right. Thank you, Phil, for that presentation. I do want to thank our sponsors before we go any further. We are brought to you by Kalani Tours, the sightseeing agency, but really do some personalized tours that help educate visitors and also provide some unique experiences. They do a volcano tour, waterfalls, but also they do a coffee tour. Start off at Kona Coffee in the morning, go into some clouded forests, come back down, and finish it with some adult beverages. Sounds like a nice time. Really appreciate them as a sponsor. The other one is Kilauea's Bar and Grill in the heart of Pahoa. Provide some unique local twists on some more traditional cuisines, some more fine cuisines. The prime rib is amazing. Fish and chips is awesome. Can't go wrong with a burger there. Indoor, outdoor dining, full bar, nice place to go. Check out if you ever come out Pahoa way. It's also a place that I frequent myself. And we do have several questions today, some good ones too. So let's dive into those, shall we?
Yeah, let's do it.
All right. First one is from Kelly Wilson from YouTube asking, is the lava lake draining or is it more just pulsating?
It seems to be pulsating and crusting over, and it does contract as it cools and it degasses. So it does actually lose some volume on its own naturally, right? So that naturally leads to us thinking that maybe it might be draining as we see the surface is lowering. But I haven't done the calculations myself, and I haven't heard anyone talk about having done them yet of what threshold you'd have to see of subsidence to then prove that you must have some drain down there somewhere that's out of sight, that you can't account for the loss of volume through degassing and cooling yet. So far, I think we're still in a range of degassing, cooling, compression can explain everything as far as a change in volume, but it is losing a little volume, it is pulsating, and even so, that small area seems to be closing in, but it's very slightly rising at the same time.
Natasha asks about the density of the lava and how it's changing. Is it still pushing up against the crust, and how does the degassing affect the lava composition?
Yeah, that's a great question. Because the gas really is the most important component of the density of the lava, right? The lava itself, density doesn't change that much, but it's really about how much gas you can entrain. That's the effective density of it there. So it does seem with a lot lower gas values being reported that the lava would be a little more dense as well, and maybe that's why it so easily is able to dive under the crust before it gets across that little pond surface. It's able to already start sinking down, right? And something's gonna be at the surface, so naturally you form a crust there, but you can imagine that the component of the flow is downwards as well. It must be downwards as well. So it's as far as the actual, the lava that's still in the pit, it's losing gas all the time. It's getting denser all the time, but I can't imagine that any of the stuff that's above it's gonna change, right? So basically the stuff below it's getting denser from losing gas all the time and getting compressed, and you are adding more lava that does have gas in it, but that's a fairly small percentage of that entire mass.
Right. So no one of consequence on YouTube asked, and that's the name, I'm not calling them that, Looking ahead at the eventual end of activity for this eruption, one could envision a 700-foot thick solid plug in Halemaumau. How would that affect future activity there? And does the density that we just talked about matter, or that you just spoke of, matter?
Yeah, so the first thing to mention is that the timeline of that thing hardening all the way through solid is decades, right? The Kilauea Iki it was 440 feet thick, right? Not 740 like this one. And 440 took, I want to say 36, 37 years to harden, solidify entirely. And so that was 4 decades. So you'd imagine if we're not quite twice that, but you'd imagine more decades than 4 would be how long it takes to harden all the way through. So that said, how likely is it that we go 4+ decades without something else happening at the summit that cuts through and affects that geometry in that lava lake? That's the most likely thing. So it's not likely to have a chance to harden before something else happens. So that means that you could have some lava in there remobilize from land adjustments nearby. That's one possibility. You could have a fissure open up through there and reactivate that. We've described the historical landscape of 1921, with the descriptions of epimagma and perimagma, right? The epimagma being that gooier kind of thing that formed that semi-solid plug that would rise and fall like a gooey piston, and then the lava would crack through there, have liquid lava filling above it, but that was essentially a ductile plug that could slide up and down, right, with lava on the outsides kind of lubricating the ring, so to speak, right? So you had like a hardening core that was involved in the whole shape of the summit lava lake. So that's a possibility, depending how long it has to form and harden and make something like that. And, if you have an eruption sooner than later, if lava keeps coming out, then you don't have to. You extend that timeline for longer and longer and longer, and you maintain liquid within there to remobilize as a small flow, or let's say you collapse through there for some reason, and then suddenly you drain lava into a new pit because you still have liquid to drain, right? That kind of thing can happen. Wouldn't last as long.
Yeah, I like to think of that area as just like a good step towards rebuilding a conduit, an open conduit to the surface, like the old lava lake was. It seems like once something happens again, that's going to be a nice shape to take advantage of if you're trying to build a conduit.
Yeah, it could be. Yeah,
all right.
Yeah.
Going into the next one. Eric asks, how does the current diffusion rate at the summit compare to Pu'u pre-2018 and 2008?
So we don't have official numbers, but by my best guess and estimates, we're somewhere around 0.5 cubic meter per second right now. The long-term average of Pu'u was around 4, so that would make it 8 times more. I want to see it peaked at as much as 6 cubic meters per second, so that would be a little more than that, and it might have been as low as 2. So at worst, it was 4 times more than now at its lowest points, is what I'd say. And it certainly ranged a lot higher, right? And Pu'u was one of those as well that were counting the whole 40-year average, 35-year average, I should say, right? Rather than the first. If you were to count only the first couple years, you'd have all the high fountain events, and you'd have a different number. So that's averaged out over the whole eruption. So yeah, it's quite a bit lower now, and it has been for a while.
Matthew asks, why do shield volcanoes specifically tend to form rift zones?
So that's a good question. I don't have like an official answer, but the things that I think about when you have shield volcanoes by definition are formed by that less viscous kind of lava. I call it runnier lava, right? So it flows further and it usually gets all the way to the shoreline and goes in the ocean, and so it makes these long, broad shield shapes, as they're called, right? As opposed to the stratovolcano, the pointy top volcanoes, to be crude about it, right? So because the lava coming out is more fluid, where does that kind of lava exist on the planet? And it exists at hotspots, and it exists at ocean ridges for the most part, right? And also rift zones on continents as well as another place where they exist. So when you have, so I mean, especially when you think about mid-ocean ridges and how mid-ocean ridges form on a surface of the Earth, when you're trying to spread, it's interesting. Plate tectonics is something we usually draw on 2D maps, right? But really, they're all curved plates that rotate around a sphere, right? And so there's geometry that's not intuitive when we're looking at it in map shape. So it turns out that when you want to split a plate and have a junction of 3 spreading centers, you need to have 3 axes at 120 degrees that make a triple junction that allows a spreading of 3 plates across a sphere. That's the natural shape that they form. So when you have that same feature being mirrored, maybe is a good way to write. There's a parallel structure at the scale of a shield volcano where similarly the ground wants to split in 3 axes, right? And normally at 120 degrees to each other. And because the magma is more fluid and more mobile, and you can have it move through fractures in the ground further away, you can build longer rift zones within the actual edifice, within the actual slope of the volcano there. So it's something about the kind of magma, the bulk, the shape of the land there, and the way the Earth naturally wants to crack. Those are all the elements of my unofficial answer there.
All right. Let's do one last one. Tanya asked from Facebook, is the lava lake, the part that's still fluid underneath the crusted surface, is it still circulating? Is it convecting, or what do you think is happening in there?
Yeah, that's a great question. I have no idea. But the interesting thing to me is how much that channelized area of the West Vent, it keeps diving under that big island, right? And it doesn't seem to slow down or pile up, or there's no change. It just keeps. It's like the escalator at the mall. Like the tracks just keep going. It just keeps going under continually over and over. It just disappears into somewhere unseen. And I would imagine that if it wasn't circulating enough to allow that to happen, right? At least at some shallower level, then you'd see some effect at that entry point. And I haven't seen any change there at all. And maybe that's coming at some point, but that hasn't. That's what I haven't seen. Right. As far as the deeper levels, I wouldn't be surprised if that thing is a really deep thing. So you might have some stratification. You might have the densest stuff, the most degassed stuff sinking to the very bottom, right? And maybe that stuff's not circulating, and only the upper part is. And that's a possibility. Where all the gas is going to want to rise up. It's going to collect probably underneath that crust. So you might have a foam layer of some kind under that crust, and that might be where all the action is happening. And it might not be that thick in the end, and you might have a stratification of much heavier stuff below that doesn't really get moved that much. That's just my guess, but I really have no idea. That's the kind of elements that we're thinking, right? The gas, the density separation of the fluid, and how it might actually stratify, and that kind of thing.
All right. Well, that does it for questions. Yeah, good questions. We're going to be premiering another episode of Drones On immediately following this live stream, so stick around. It's only going to be a couple minutes. Take you back to May 4th, 2018, and some of the footage that was recorded that day. Tell a little bit of the story. And if you enjoy this content, make sure to like, subscribe, check us out on hawaiitracker.com. And if you feel like making a monetary donation to help support us, don't have to, but we take those on hawaiitracker.com/support. We appreciate everybody that tuned in today.
Mahalo, Dane. Mahalo, everybody, for your questions, for your support. So for Hawaii Tracker, another volcano update complete. He's Dane DuPont. I'm Philip Ong. Aloha, everyone.